And our topic is safety practices for the production of spreads. Ayan. By the way, my name is Joanne Tito, and I'm also with the Janssen people. Okay, we're so happy po na dami for this morning. Thank you po for joining us. After the presentation, we are allowed to ask questions to Miss Olga. So, without further ado, expand our knowledge with this informative webinar prepared by Miss Olga. Hi, Miss Olga.
Okay. So today we'll be discussing food safety practices for the production of spreads. Last Wednesday, we've talked about what hot filling is, the principle behind each process of hot filling, which are pasteurization of the product, filling and capping, holding, and rapid cooling. We've also talked about the advantages and disadvantages of hot filling and reasons of spoilage if the product was not thoroughly processed. So today we will focus on breakfast spreads and the food safety issues linked to these products, particularly on peanut butter, jams, and jellies. So the points of today's discussion will be the following. First, we will define what breakfast spreads are and its categories. Then the food safety issues linked to breakfast spreads, particularly on salmonella contamination in peanut butter and yeast and molds in jams and jellies. So what are breakfast spreads? As the term suggests, these are foods that are applied onto breads, crackers, and similar foods, generally with a knife. So it is used to enhance flavor or texture of the food. So what are the different categories of breakfast spreads? Actually, there are 5 categories. First are the fat spreads with the use of edible oils. They are described as solid, spreadable emulsion that have a fat content of 10% to 90%. Examples are margarine and butter. Second is the dairy spreads, which are milk products relatively rich in fat in the form of a spreadable emulsion that remains in solid phase at a temperature of 20 degrees Celsius. Examples are cream cheese and spreadable cheese. So there's also nut butters. As its name suggests, are mainly composed of nut paste and stabilizer and may contain sweetener, salt, emulsifier, and other ingredients. Examples are peanut butter and other butters made from nuts such as hazelnut and almonds. There are also what we call as yeast spreads, which are developed using yeast byproducts of the alcohol beverage industry and marketed as a highly nutritious breakfast spread. This is actually one of the common breakfast spreads in Australian homes with famous brands such as Vegemite and Marmite. So the last category is the fruit butters and preserves, which are produced by preserving the fruit with sugar and allowed to be thickened to some degree. Examples are fruit jams and jellies. So what are the food safety issues linked to breakfast spreads? Actually, the food safety issues that can be associated to a particular product may depend on the pH, and water activity of that product. Last Wednesday, we've mentioned that pH is and what commodities of or food products are considered as high acid and low acid foods. So high acid foods include fruits, jams, jellies, while low acid foods include vegetables, meat products, and baked goods. But today, we will talk about water activity and its importance to predict the stability and safety of a certain food product. So for this presentation, we will just focus on the food safety issues linked to peanut butter, which is a low water activity food, and jams and jellies, which are considered as intermediate moisture foods or IMF. First, let's discuss what water activity is. So it describes the available water for microbial growth or the available water which can be utilized for biochemical reactions and initiate microbial growth. So it ranges from 0, which is bone dry, to 1, which is pure water. So here is an illustration describing the role of water activity in microbial growth. So let's take a look at the free water here on the right side. So suppose this is the food and there are lots of free water. So there are also lots of water that can be utilized by the microorganisms. So now going here to the illustration of the bound water at the left side, you can see that microorganisms cannot utilize the water present in the food since they are already bound by the white components, this one, which are solutes we use during processing. Examples are sugar and salt. Here is the table of water activity of certain foods with the corresponding microorganisms that may grow in the given water activity range. So the lowest water activity at which spoilage bacteria can grow is 0.9, as you can see here. These are bacteria. And then from um, zero point 0.6 here, from zero point 0.6 up to zero point 0.9, this is the water activity range where yeast and molds start to grow. So from here, from zero point 0.6 to zero point 0.9, bacteria is not an issue anymore. Also, you may notice that the higher the water activity, the faster microorganisms will be able to grow, resulting in higher standards of food storage, which is proven by the highly perishable foods, this one, here classified as having water activity range of 0.95 to 0.99 and definitely needs higher forms of processing and storage methods. Now let's discuss peanut butter, which is under the nut butter category of breakfast spreads. So nut butters are considered as low water activity foods, meaning they have a water activity of less than zero point 0.7. Peanut butter specifically has a water activity of zero point 0.2 to 0.45, pH of 6.1 to 6.4, and fat content of 55%. Now, with the water activity as low as this, we can already infer that bacteria cannot proliferate in peanut butters, and we should just probably be concerned with molds. However, take a look at these international headlines on salmonella outbreaks in peanut butter. So here, this is the first documented peanut butter outbreak, which occurred in April to June 1996 in South Australia, caused by Salmonella bandaka, with a total of 28 cases of infections. So 10 years later, the first peanut butter occurred in the US in 2007, where a total of 628 people were infected in 47 states, and 20% of these people were hospitalized. Then, in 2009, there was a multi-state outbreak associated with Salmonella typhimurium in peanut butter and peanut products. This outbreak caused 714 cases in 46 states and 1 case in Canada, 171 hospitalizations, and 9 deaths. So locally, we also have peanut butter recalls due to salmonella contamination as ordered by either BFAD or what we call now as FDA or DOH. So in 2009, due to the outbreak in the US, peanut butter products from Kellogg's, a US-based food company, were voluntarily recalled by the company due to salmonella concerns. Also in 2009, DOH ordered a nationwide recall of Ludy's peanut butter after it tested positive for salmonella. In 2014, Arrowhead Mills peanut butter has been voluntarily recalled as initiated by the company after several batches tested positive for salmonella. So we can see through these headlines that salmonella infection is a serious matter as it can cause deadly infection, especially in young children, pregnant women, the elderly, and immunocompromised individuals. Now, if there is salmonella in the peanut butter, what are the required heating conditions to destroy the salmonella cells? So typically, salmonella cells can be destroyed by heating the food products at 71 degrees Celsius for a few seconds. However, there has been a study that salmonella can still survive in peanut butter heated at 90 degrees Celsius. So in a study by Shachar and Yaron, the required heating conditions to inactivate salmonella cells are the following. So if the peanut butter contaminated with salmonella would be heated at 70 degrees Celsius, then we should heat it at this temperature for 4 hours. If it would be heated at 90 degrees Celsius, we need to heat or process the peanut butter for 1 to 2 hours. However, we cannot simply heat the peanut butter as such, as this will affect the quality of the product, which may lead to denaturation or increased browning of the peanut butter. Now, why does salmonella survive in peanut butter? The main reason is the high fat content of the peanut butter that might protect the cells during heating. And another possible reason is the heterogeneous nature of peanut butter matrix that inhibits the effectiveness of the thermal treatment on the product. So please take note that only a very few salmonella cells, like 3 cells per gram or 3 colony forming units, CFU, may be required to cause infection when consumed. What are the possible points of entry of salmonella during peanut butter processing? So according to studies, there are 5. First is the contamination of peanuts used as raw material, which usually happens during growth, harvest, transportation, and storage. Second is the post-process contamination, either during repackaging or during addition of other ingredients such as sugar and stabilizer. Third is the third possible source of contamination is the hygiene or personal hygiene of the personnel. Fourth is a cross-contamination of the finished product with raw materials. We all know that in a processing facility, the receiving and storage of raw materials should have a separate room from the packing area and the storage of finished products. So hiwalay dapat yung raw and processed. Fifth possible source of contamination may be through the use of unsanitary equipment and utensils. These 5 possible sources of contamination can be addressed by proper implementation of good manufacturing practices or GMPs. So just a recap of what GMP is. GMPs are good manufacturing practices that are the basic operational and environmental conditions required to produce safe goods. They actually address the following. So the environmental control, um, the environment or the premises of the facility, including the construction of the building, personnel practices, including the personal hygiene and covering of injuries and wounds during processing, shipping, receiving, handling, and storage, including storage practices of all materials needed for the processing of the product, pest control, sanitation, which includes cleaning and sanitizing procedures before, during, and after processing, equipment maintenance, including calibration of all equipment and instruments, recall and traceability, and water safety. Now, let's discuss the reasons for salmonella contamination in peanut butter that occurred in the 2009 international outbreak in the US that I have mentioned earlier. So, based on the findings of US FDA, the improper implementation of GMP was the main cause of contamination. So, here are their findings. So, unclean equipment and utensils were used. They also used the same sink for hand washing and cleaning mops. The processing area was not properly sanitized that eventually allowed growth of molds. And these 3 points violate the principle of sanitation in accordance to GMP. The raw peanuts were stored next to the roasted peanuts, which violates the principle of appropriate handling and storage according to GMP. Pests roam freely in the facility, meaning there was no pest control program in place. Also, there were gaps in the ceilings that allowed drips inside the plant and onto the products. The products are stored near cracks in floors and walls. These 2 points violate the principle of maintaining environmental control on the processing facility in accordance to GMP. The oven temperature during roasting of peanuts was not properly calibrated and regulated, and it was reported that the employees rely on the color of the roasted peanuts more than following the required roasting time and temperature. So this means there was no equipment maintenance in place. Another reason is after receiving positive salmonella results for the peanut butters and peanut products, the manufacturer still resubmitted the sample, hoping for negative results, which violates recall and traceability, and they still continued to use contaminated equipment without first cleaning it, which violates the principle of sanitation. So there were many violations na ginawa nung manufacturer kaya nagkaroon ng contamination sa peanut butter. Now let's discuss intermediate moisture foods, where jams and jellies belong. Intermediate moisture foods, or what we call as IMF, are foods with water activity of 0.6 to 0.9. They are partially dehydrated foods with dissolved solids in the form of sugar and salt to inhibit microbial growth. Jams and jellies have water activity values of 0.8 to 0.9, pH of 2.5 to 3.45, and total soluble solids, or the sugar content, of values of 65 to 68%. So going back to the table with the water activity ranges, we can see that only yeasts and molds can proliferate in IMF, such as jams and jellies. So our main concern here is to inhibit growth of yeast and molds. Actually, jams and jellies are generally safe when produced under controlled conditions, especially with their high acidity, which inhibits growth of bacteria. Now, the preservation principles of jams and jellies are quite complex, but mainly involve the correct combination of acidity, sugar, and pectin content. The following are some control measures to ensure safety of jams and jellies. First is we have to control the total soluble solids, or the sugar content, of the product, which should reach at least 65% to 68%. So the degree breaks and the percentage that I've mentioned are just the same. So if the sugar content is lower than these values, especially if the product is not boiled enough to reduce moisture content, molds may start to grow on the surface of the product. However, if the sugar content is higher than 68%, the product may become too stiff and the sugar might start to form crystals on the product. Second is we have to control the water activity of the product, which is done by allowing the product to boil for a specific period of time to remove excess moisture and allow it to become concentrated. Third is we have to control the pH of the product through addition of appropriate amount of either citric acid, tartaric acid, malic acid, or sodium bicarbonate, depending on the actual pH of the fruit. The pH actually affects the gelling properties of the product and should be between 2.5 to 3.45 to form a good gel. Last but not the least, we should follow the proper pasteurization of the product, which is done through boiling. Pasteurization is done for two reasons. First is to kill the pathogenic microorganisms that may be present in the raw material and other ingredients. And second is to reduce the water content of the mixture and concentrate the fruit and sugar. So, we're making the free water, parang binabound natin yung free water na present dun sa product. After pasteurization, the product should be hot filled into the corresponding sterilized containers. And the principle of hot filling also applies in jams and jellies. So, proper storage. Jams and jellies that are made according to the correct recipe and sanitary procedures will have a long shelf life. So, jams and jellies stored in glass jars will have a longer storage shelf life than those packed in plastic jars. In glass jars, up to 12 months, while those packed in plastic jars up to 4 months. This applies to unopened jams and jellies, which should be stored in a cool, dry place away from direct sunlight. What causes spoilage in jams and jellies? This may be caused by either the imperfect sealing of the product, including the headspace, meaning no vacuum or not, or the product is not hot filled, and possibly improper storage. So the following are some prevention measures to improve the quality of jams and jellies and eventually extend their shelf life. So, containers should be sterilized. If glass jars would be used, you may do this by heating the jars and lids in boiling water for 5 minutes and air dry. So, if plastic jars would be used, you may sanitize them by washing with 50 to 100 ppm chlorinated water and air dry. Also, ensure use of containers with no dents and rusts. Third is ensuring appropriate seal and vacuum, which can be done by following proper hot filling procedure. Store the finished and unopened products in cool, dry place. And remember to refrigerate the products once opened. That's all. Thank you.
Thank you, Miss Olga, for the informative presentation for this morning. And now, the question and answer session is now open. If you want to ask questions, please raise your hand. Anyone po? May questions? Ang question ni Ma'am Lynn sa turno, need pa po ba i-sterilize yung PET jars?
Yes po. Kailangan siyang i-sterilize para malinis yung product. So, we can do this by i-wash po siya sa 50 to 100 ppm chlorinated water. Tapos po i-stay po siya for ilang minutes. Then itapon po yung yung chlorinated water, then air dry. Huwag pong pupunasan ng cloth. Air dry lang.
Okay. Okay, Ma'am Lynn, nasagot po ba yung tanong nila?
Chlorinated water po. So, kailangan po i-compute yung 50 to 100 ppm. Tapos yun po yung ilalagay dun sa, kahit Zonrox lang po. Tapos i-compute nyo po yung ppm. Tapos yun po yung i-stay nyo dun sa packaging, sa container.
Okay. Miss, sa All Bicol, may question daw po sila. Go, ma'am.
Tanong ko lang, halimbawa po, medyo, di ba, karamihan na yung manufacture natin. Halimbawa po, so, possible po ba lahat ng mga bote?
Medyo choppy.
Dadaan po ba talaga sa pagbubukas? Or naka-sterilize na po yan from supplier na mga bottle po?
Pwede mo pa ulit yung question.
Hello ma'am, katulad po. Halimbawa, di ba, nasa volume order na, nasa volume process. Tapos ngayon, ang mga bote po natin, tanong ko lang, katulad po sa Philpet, tanong ko lang ma'am kung yun po ba ay naka-sterilize na. Sige ba? Halimbawa ma'am, Bihan, so possible po ba ang mga bote or dati na siya nag-sterilize from supplier, katulad ng...
Actually ma'am, lahat po ng mga products ng Philpet is bagong gawa. So, parang technically, malinis sila. Kaya lang, we have to ensure pa rin na linisin pa sila pagdating sa facility nyo, processing facility nyo. Kasi syempre yung storage niya, yung handling ng mga containers is baka mamaya matagal, ganyan. So, possible na merong contamination. So, kailangan pa rin po nating linisin siya pagdating sa sa facility natin. So, before siya gamitin, sterilize po ng 50 to 100 ppm na chlorinated water. Tapos i-air dry po.
Okay, ma'am. Sige po, naintindihan.
Okay, sige po.
Okay, ma'am. Thank you.
Tapos
Thank you po.
Follow-up question si Miss Lynn sa porno. Sabi niya, soap pa po ba or yung wash lang?
I-soak po for siguro at least 5 minutes. Then, tanggalin nyo na po. Then, air dry.
Okay. Any questions pa po? Ikaw, Dayan, may question ka, Miss Olga.
Miss Olga, pa-explain na lang sa viewers natin kung bakit nyo po pinakita yung mga cases.
Ano po, actually, peanut butter is medyo complicated siyang product, no? Kasi, hindi lang, ah, hindi lang, ano ba 'to? Complicated siyang product kasi puwedeng ma-contaminate siya ng salmonella. So, yung salmonella kasi puwede siyang maging deadly. So, pinakita ko lang po yung cases para para maging aware tayo na kailangan lahat safe kasi puwede tayong maka-hospitalize ng mga tao, ganyan. Or puwedeng if, mahina yung immune system nila, kunyari bata, ganyan, or sobrang tanda na, puwede silang mamatay. So, kailangan talaga lahat safe. So, yung sa peanut butter po, ah yung para ma-ensure natin na safe yung product, kailangan po nating i-follow yung GMP. So, yung mga nabanggit ko po kanina. So, lahat po yun 'pag peanut butter. Tas actually, sa peanut butter hindi lang salmonella, hindi ko lang po sinama sa presentation, pero hindi lang salmonella ang problema niyan kasi meron din po tayong tinatawag na aflatoxin, kung familiar kayo, na nire-recall ng FDA yung mga peanut butter 'pag meron silang nakitang, presence ng aflatoxin. So, yung aflatoxin po, molds din yun, gawa yun ng molds. Toxin siya na pino-produce ng molds na, na nakukuha or parang molds na naggo-grow dun sa peanuts. So, part ng GMP, kailangan malinis lahat ng, raw materials natin. So, yung peanuts na ginagamit natin for peanut butter, kailangan, walang molds, walang off odor, off color, gano'n. So, dapat lahat fresh para safe 'pag 'pag natapos na until peanut butter.
Miss Olga, meron pa. Kasi mostly sa mga participants natin ngayon is Yema spread yung product. May idea po ba sila sa procedure?
Sa Yema spread, actually di ako masyadong familiar pero dairy spread siya, no? So, possible na yeast and molds din yung kalaban natin dito. So, yun lang, para siyang jams and jellies din. Pero I think mas, ah, actually sinearch ko siya, ang dairy spreads ay mataas ang water activity. Mataas din yung pH niya or acidity niya. So, nabasa ko na mas kailangan niya ng mas mataas na temperature. Though hindi po ako masyadong familiar, pero nakita ko lang na dapat mas mataas yung temperature niya kaysa sa jams and jellies. So, sa jams and jellies, 'di ba, 'pag gumagawa tayo mga ano lang 90 degrees ganyan, pasteurization lang. Pero 'pag dairy spreads, kailangan nating i-sterilize, which is kailangan umabot yung temperature natin up to 120 degrees pataas. So, yun lang po. Pero ang kalaban natin is yeast and molds. Yun lang po.
Okay, thank you, Miss Olga. Wala na po bang pahabol na questions?
Ay, wait lang po, sorry. Yung sa dairy spreads po, ang nabasa ko po, ang kalaban pala natin ay Clostridium botulinum. So, yung Clostridium botulinum, bacteria siya na nakikita sa mga low acid foods kagaya ng dairy spreads. So, kailangan nating i-sterilize para mapatay natin yung Clostridium botulinum. Ang Clostridium botulinum, kung alam niyo lang po, no, isang cell lang niya, makakamatay po siya. So, kailangang malinis lahat and proper yung temperature.
Okay. Wala na pong follow-up questions. Okay. Wala na. Okay. I think this is the end of our webinar po. For more questions, please email us at marketing.philpetinc@gmail.com. And see you po on our next webinar. Thank you and stay safe, everyone. God bless po.